Hello dear students, this is Bhaskar, working as Assistant Professor in the Department of Electronics and Communication Engineering, SJBIT Institute of Technology, Uttarahalli Road, Bengaluru. Today we are here to discuss on the feedback amplifiers, which is Module 3 of Analog Electronic Circuits. Okay, these are all the learning objectives that we have for today's discussion. Number one, we'll understand what is a feedback, why do we require it, the general structure of the feedback, and finally the properties of the feedback. So by the end of this lecture, all of us must be in a position to answer to these questions, and also we should have understood by the end of the discussion. Okay. Before I formally move on to the definition of what is a feedback, probably I felt of giving a analogy, because analogies will always make the concept very clear. Okay. So keeping this in mind, I'll take an analogy of a classroom scenario where a faculty is giving an assignment to the student. And let's say faculty gives an assignment and student takes it, understands the question, writes an answer, submits it back. Now the faculty in turn is going to do what? Is going to evaluate it. Correct? So we started from the faculty inputting the student an assignment and student giving out the assignment, submitting it to the faculty, and faculty in turn evaluating it. So please understand the flow and what is going to happen now. Let us consider two cases. Case number one, a faculty will award 10 on 10 and also put a comment stating that you have done a good job because the answer is very apt. Case number two, faculty will write few comments because the answer is not appropriate. Probably the student has missed out few points and he would get 5 on 10, let us say. So two different cases. Case one, which is giving a positive feedback to the student. Case number two, which is giving a kind of negative feedback, because there are lacunas that were seen in the assignment. So student in both cases will understand that either he has understood the concept very well in case of positive feedback, and in case of negative feedback, he will get to know that these are all the mistakes that I did and I should rectify it. So both kind of feedback will really be helpful for a student. So this is the concept of a feedback. So feedback is kind of used in all our daily life. You go for a movie, you want to give a review, so that's a feedback that you give. Correct? You purchase a product, let's say on a online portal, and you will again give a feedback after you get the product. So everywhere feedback matters a lot. So is the case even with the electronic circuits as well. Okay? So feedback is a very important concept. So, and that's why we are here today. So now let's look at the formal definition of what is a feedback. Feedback is basically a process where you take a part of the output and feed it back to the input. Now when you are taking a part of the output could either be a current or a voltage quantity. Okay. So this is analogous to the example that I gave earlier, where a faculty gives the gist of the answer what he has written in terms of the comments or in terms of marks. Correct? He wouldn't again write an essay saying that this is what you did in line 1, line 2, line 3. So he only gives the gist of the final result, and that will be either in terms of marks or in terms of few points. So the same thing happens even with the circuit also. A part of the output is taken and fed back to the input, and that is for the goodness of the amplifier. Now comes the next question. What is a feedback amplifier? So if feedback is taking a part of the output and feeding it back to the input, feedback amplifier is nothing but an amplifier which uses the principle or the concept of the feedback. Okay, and that is what is termed as feedback amplifier. So as it was made very clear in the analogy that there could be two different types of feedback. One is negative feedback, other one is positive feedback. We have the same thing even with the circuit also. Okay. Now let us look at the general feedback structure of an amplifier. How will the general feedback look like? And remember, when I am quoting the general feedback structure here, I am pointing at the negative feedback. It means that this block diagram is applicable to a negative feedback. Now the very first question that comes to me is, how do I identify it? Before I get into it, let us get familiarized with the different blocks that we have got. Source, all of us know what it is. It's basically the the block where the signal would come out, which you need to amplify. So this is the source part. And we indicate that source output as excess. Remember, it is just a quantity and this could be either a voltage or current. And so is the case with all other X terms that we have in the block diagram. So then let us come to this summary in the later part. We'll move on to the next block, which is amplifier. We all know what is an amplifier, which is nothing but an electronic circuit which strengthens a weakened signal, and we get the output as X naught, and that is further fed to the load. In return to the input side, we have something coming from the feedback network. This beta is the one which takes a part of the output and feeds it back. So this is where the sampling is happening. So we call this as a sampler block, where we take or we sample a part of the output and feed it back to the input. And what amount of output goes in is decided by this beta factor. So I can indicate this beta factor as what? The output of the beta, which is XF, divided by the input given to this beta block, which is X naught. So I can indicate beta as this. Now that XF will get into this input side. Now we have two things here. If you can see a summer circuit, one of the input that is getting in is XS, which I have written it as plus. The other input which gets in is XF, which I have written it as minus. So which means that these two guys are in out of phase. So it means that they get subtracted. So Xi could be written as what? XS plus XF. Finally, this is the amount of voltage or the current that gets into the amplifier, and further amplification will happen. So this A, what is indicated here, is only for this block, and which is termed as open loop gain. A is termed to be open loop gain, because this is the block which will not have any feedback as such, and later on externally you connect a feedback network. That is altogether a different story. But when you consider that block alone, what is the input that is getting in? Xi. What is the output? You get X naught. So A can be written as X naught divided by Xi. This is what is termed as open loop gain. Okay. Now we'll come to the point as to how to identify the given block as a negative feedback or a positive feedback structure. So if this XF is with a negative sign, or if they are out of phase, we call it as a negative feedback. So negative feedback means that XF and Xi are 180° out of phase. If I want to have a positive feedback, then what should I do? It's very obvious now. Can somebody tell me what is that I'm going to do now? Yes, we are going to make this positive. That's it. XF becomes positive. So it means that they are in phase. Both the signals are in phase. So it is 0°. So this is how you basically identify the structure as a negative or positive. Is that clear? I hope things are very clear to you. Now what I'll do is, before we move on to the next part, I would like to highlight one thing here. Let me take a red ink and try to write a block here. Let me indicate a block here. Now what is this block? Now this block, I'm including both the amplifier as well as the feedback network. Now whatever you see within this block, within this dotted box, will contain amplifier and the feedback network. So if I want to find what is the gain of this entire block, which consists of the open loop amplifier as well as the feedback put together, is what is termed as the closed loop gain. If I want to find the gain, I'll be indicating it as AF, and which is nothing but the closed loop gain. Okay. Now how do you define this closed loop gain? What is the input that is getting into the box? You look at only the dotted box and don't think of anything which is there inside it. So think that it is one big box which is an amplifier box for you. Okay. And what is the input that gets in? It is XS. What is the output you are getting? It is still X naught. Remember, it is still X naught. So I can write AF as, let me write that here. AF is nothing but the output X naught divided by input XS now. This is the equation for open loop gain. Now you should be familiar with these equations now. What is the equation for closed loop gain and open loop gain? So this is the gain equation for the closed loop, and this is the equation for the open loop gain, which was told earlier. So I think till here things are all very clear to you. So this is a very general block where I have not indicated whether it is a voltage or a current, because we have to be very generic in the beginning, and later on we'll start segregating things in the right way. I hope till this point things are all very clear to you. Yep. Okay, we'll move on to the next thing. Now the question comes as to what is the equation which gives me a relation between the open loop as well as the closed loop. Why would I require it? Because normally when I design an amplifier initially, I would have designed this A. Now I need to design a closed loop or a amplifier with feedback, with a negative feedback, remember, with a negative feedback. So I need to have a relationship between the open loop as well as the closed loop gain. So let us have a relationship now. Let us have a relationship. So what is the equation that I have for AF? We know AF is equal to X naught divided by XS. We also have few more relations which was written there in the block diagram. So what is that? I can write XS which is equal to XI plus XF. Remember we had written XI equals XS minus XF. Okay. Now what is XS? XS indicates the source signal. What is XI indicating? Input to the amplifier. What is XF indicating? XF is indicating the feedback signal. So this is one equation. What is the second equation that we wrote? A. A is what? X naught divided by Xi. What is the third equation that we wrote? Beta factor, which is equal to XF divided by X naught. So these were the equations that we had written earlier. We are going to use these equations now. So I can use the very first equation, which is XS here. So what I'll do? I'll write X naught divided by Xi plus XF. Further, what I'll do, just to deduce the equation in terms of the open loop gain A, and you can as well indicate the beta factor because it obviously comes into picture. We're talking about negative feedback, so beta factor has to come into the equation. So to bring in those, what I'll do, I'll say I'll divide both numerator and denominator by Xi. So what you will get? 1 plus XF divided by Xi. Now you have a quantity for X naught by Xi, which is what? The gain, open loop gain. So I can make this term as A. But in the denominator, I should somehow try to have a factor which gives me A and beta. So I can write XF divided by Xi could be written as what? XF divided by, let us say, X naught into X naught divided by Xi. Now you have what is XF by X naught. What is XF by X naught? It is nothing but beta. I can write this as beta times of A. So that would now imply AF is equal to A divided by 1 plus A beta. This is the equation what you get. Now this is the closed loop gain equation. And that is for a negative feedback. Very, very important. We should not forget this. We have reduced this equation for a negative feedback. Now people will have a curiosity. What if I use a positive feedback? What would happen? Will the equation for AF change? We have to ask ourselves is, when do I go for a positive feedback? Because when I give the positive feedback, go back to the analogy that I gave. If a student gets a positive feedback, what is going to happen? It will boost his confidence, correct? He will anyways have a confidence, but it will boost. Probably in the very first instance, if the assignment is given and if the student is not too confident, and surprisingly if he gets 10 on 10, he would have written the answer correctly, but he is not confident. Surprisingly, if he gets 10 on 10, obviously he'll be very surprising, and it will obviously boost the confidence. Initially the confidence will be low, and later on it is going to boost the confidence, correct? So in the same way, when I go for a positive feedback, because I just wanted to put this word, because as we're talking about the feedback, negative feedback we're going to talk a lot, but I felt I should also talk about the positive feedback. So let me put that here. As far as the positive feedback is concerned, we normally use it in the design of oscillators. Why oscillators? Because when it comes to oscillators, initially there will be noise signal, and you have to amplify that noise signal as well as it should shape the noise signal so that you start getting either a square wave or a sine wave or whatever oscillator you have designed. Correct. So to get this kind of nice shape wave which has got a very decent amplitude, obviously the feedback should boost the signal, and boosting can happen only when you give a positive feedback. Just think of the analogy, you will really be able to correlate this with that. Okay, so things are going to be easier for you, that's all. So positive feedback is basically used for oscillator design, and negative feedback is used to design an amplifier. One more thing to quote here. What if the equation is asked for AF in case of positive feedback? We have got A divided by 1 plus A beta. The equation here becomes A divided by 1 minus A beta. That is the only change what you observe in case of positive feedback. Okay. But otherwise, there are so many other differences as such. But from the equation point of view, this is what you observe. It becomes 1 minus A beta. That's clear. So with this preamble of the feedback introduction, we shall move further into getting to know why do we require a feedback. These are all the summary that that is given here, which we have already discussed. So closed loop and open loop gain we discussed. Closed loop gain is equation is AF divided by A equals A divided by 1 plus A beta. Feedback factor is basically a beta, and we call this A beta factor as the loop gain. This is what is termed as the loop gain, because A and beta will come within one loop. So when you find this factor A and beta, we call it as the product together is called as a loop gain. And this is the amount of feedback which you can again notice here. This is the amount of feedback which is given back to the input side. Okay, so with this, now we'll get into why do we require a feedback. Any good idea about why we require a feedback? What makes us to have a negative feedback, specifically negative feedback? It is quite impossible to think of any electronic circuit without some feedback. Even human beings, without feedback, how can we lead life? Somebody should say you're right or you're wrong. Otherwise, every time if you think that you're always right, no. Many a times we go wrong. Correct? So somebody should be there to give us a feedback. And so is the case with all electronic circuits. So it's quite impossible for any of us to think of any electronic circuit without a feedback. And you would have observed that in control systems. Correct? So we'll get to know what are all the advantages of a negative feedback. One is desensitizing the gain. What is the meaning of desensitizing the gain? If at all the gain changes, what could be the reason? One simplest reason, most simplest and very important in fact, reason is the change in the temperature. If the temperature changes, automatically the parameters in the transistor will vary. We either use a JFET or a MOSFET or a BJT for the design of transistors. Correct? So all these are very temperature dependent. They are very sensitive to the temperature. When temperature changes, automatically the gain is also going to change. So with the use of negative feedback, I'm able to achieve this. I can desensitize the gain. Important application or advantage. Reduce the nonlinear distortion. Why will the nonlinear distortion come into picture? Nonlinear distortion appears because the device is nonlinear in nature. You take a transistor, you write the VI characteristic of a diode. How does it look like? Will it be a straight line? Even though we approximate it to be a straight line, it is not a straight line. Correct? You will always get a kind of exponential which is nonlinear in nature, and so is the case with the transistors. So all the semiconductor devices, most of the semiconductor devices are nonlinear in nature. So we have to take care of the distortion that would appear because of nonlinearity. So we can reduce the nonlinear distortion using the negative feedback. Reduce the effect of noise. Whatever the noise that appears either internally or externally, the amplifier must be in a position to cope up with it. Correct? So it should amplify only the actual signal, and it should be able to separate or segregate out the noise and suppress it or minimize it. So effect should be minimized, and that could be achieved using the negative feedback. Control the input and output impedance. The very important parameter or the characteristic of an amplifier is anyway that should have a good gain. At the same time, the amplifier, ideally speaking, it should have an infinite input impedance and zero output impedance. But if you consider the case of a CE transistor, can somebody tell me which impedance will be more? It is the output impedance. Correct? We are kind of lagging behind in that. So I should somehow try to think of controlling this input and output impedances. So feedback will provide. We'll see how and why it happens like. And finally, extend the bandwidth of the amplifier, because amplifiers must be in a position to take any kind of signal. When I say any kind of signal, it is in terms of the frequency, starting from the least possible frequency till the highest possible value of frequency. The amplifier must be in a position to amplify it in the same way. It should not change its gain value depending on the frequency. So I should have a good bandwidth. So that is what is basically the bandwidth of the amplifier, and we are able to extend the bandwidth of the amplifier using what is called the negative feedback. So what we have got is all these advantages, and that is why we go for negative feedback. I hope these points are very clear to you. Yep. The most important thing now is how are we able to achieve all those desirable properties that were stated earlier? It is at the cost of the gain. So there is always a trade-off between the gain and the other parameters that we just discussed in the previous slide. Okay. So this point is just to quote why positive feedback is basically used. It's used for oscillations, that as was told earlier. So now let us look at the properties of the negative feedback, and probably one more thing here. The equation which we had written, AF equals A divided by 1 plus A beta, this equation is very clearly telling you that AF is A times of 1 into A times of 1 divided by 1 plus A beta. So there is a reduction of AF. So AF is always lesser compared to A, and it is a very obvious thing. So the open loop gain is always higher compared to the closed loop gain. So this is the point. So this is what we are losing, and at this cost we are able to get these advantages. And there are many multiple advantages of negative feedback as well. Okay? But these are all the main advantages of a negative feedback. So I hope this point is very clear to all of you. So with this, let us look at the properties of the negative feedback again. We'll try to prove how basically the gain stabilization happens, how there is an increase in the bandwidth, how the distortion will reduce, how the noise is going to get reduced, how input impedance increases, how the